Hey folks, Mike Johnson here. If it's got wheels and an engine, you're in the right place. On this channel, we dive into car repairs, maintenance tips, and everything you need to keep your ride running smooth. If you're into cars and want to keep learning, don't forget to hit that like button and subscribe. It really helps the channel out. All right, enough talking. Let's get into it.
In the automotive world, displacement, often abbreviated to cc, is a key term used to describe an engine's capacity. This measurement is of considerable importance in assessing the power of a vehicle, directly influencing its performance. This article will look at the meaning of engine cc and explore in detail its relationship with power. 1.1 What is engine displacement, cc? Engine displacement is a measure of the total volume of the engine cylinders. It is generally expressed in cubic centimeters, cc, or liters. Displacement is an important indicator of an engine's ability to produce power. More precisely, displacement is determined by two main parameters, the stroke and diameter of the engine's cylinders. Stroke represents the distance the piston travels inside the cylinder, while diameter is the width of the cylinder. These two measurements together determine the total cylinder volume, and therefore the total engine displacement. The relationship between engine displacement and power is often straightforward. In general, an engine with a larger displacement has the potential to produce more power. However, effective power also depends on factors such as compression ratio, engine technology, efficiency, and other design considerations. Displacement is commonly used as an engine rating criterion, particularly in the context of cars, motorcycles, and other types of vehicle. Consumers often use this measurement to assess an engine's overall performance, and to make comparisons between different vehicle models. 1.2 Units of measurement. Displacement is a crucial measurement in the automotive world, and its expression can vary according to the units used. The two main units of measurement are the cubic centimeter, cc, and the liter, L. Understanding the relationship between these units offers essential insight into an engine's capacity. Cubic centimeter, cc. The cubic centimeter is the most commonly used unit for measuring engine displacement. A cubic centimeter is equivalent to a cube with each side measuring 1 centimeter. Thus, a 1000 cc engine has a total volume of 1000 cubic centimeters in all its cylinders combined. This unit is practical for small to medium-sized engines, offering precision adapted to the compact dimensions of automotive engines. Liter, L, another unit frequently used to express cubic capacity is the liter. 1 liter equals 1000 cubic centimeters. So a 1.5 liter engine has a total displacement of 1500 cubic centimeters. Using the liter as a unit of measurement offers a more intuitive scale for assessing engine size, especially for vehicles with medium to large engines. The conversion between these two units is straightforward. 1 liter equals 1000 cubic centimeters. So an engine's displacement can be easily converted from one to the other by multiplying or dividing by 1000. This conversion is useful for comparing engines expressed in different units, and makes it easier to understand vehicle specifications. In short, whether you encounter engine specifications expressed in cubic centimeters or liters, it's essential to recognize this duality of units and to be able to make simple conversions for a complete understanding of engine displacement. The relationship between displacement, cc, and power. The relationship between displacement and power. An engine's displacement is closely linked to its ability to generate power. Understanding this relationship is essential for assessing a vehicle's overall performance. Explore the fundamentals of this complex relationship. Basic principles. Displacement size has a significant influence on engine power. As a general rule, an engine with a larger displacement has the potential to produce more power. This is because a larger displacement allows a greater quantity of air-fuel mixture to be admitted into the cylinders, promoting more energetic combustion. However, it's important to note that effective power does not depend solely on displacement. Other factors such as compression ratio, engine design, and electronic management all play their part in determining the final power available to the driver. Compression ratio. The compression ratio, expressed as the ratio between maximum and minimum volume in the engine's cylinders, plays a crucial role in transforming cubic capacity into power. A higher compression ratio enables more efficient combustion of the air-fuel mixture, improving engine efficiency and increasing power output. However, a higher compression ratio can also lead to increased mechanical stress and require higher quality fuels. Engine designers therefore seek a balance between compression ratio, displacement, and other parameters to optimize performance. Additional factors: in addition to displacement and compression ratio, other factors influence engine power. Engine technology such as direct fuel injection, turbochargers, or superchargers, together with advanced electronic management, optimize the use of displacement to produce more power with greater efficiency. In short, although displacement is a key indicator of an engine's ability to generate power, it is important to consider all the elements of the system when assessing a vehicle's overall performance. Technological advances continue to redefine the relationship between displacement and power, offering innovative solutions for optimum performance. Displacement and fuel consumption. The relationship between engine displacement and fuel consumption is a crucial aspect of vehicle design, directly influencing fuel efficiency. Explore the various facets of this complex relationship to better understand the impact of displacement on fuel consumption. Effect on fuel consumption. Displacement size often has a direct correlation with fuel consumption. In general, engines with a larger displacement tend to consume more fuel, especially when subjected to high loads. This is due to the need to emit a greater quantity of air-fuel mixture to maintain power. However, it's important to note that other factors, such as vehicle weight, engine design, and onboard technologies, can moderate this relationship. Carmakers are constantly seeking to optimize the balance between displacement-generated power and fuel efficiency to meet increasing fuel consumption requirements. Technological developments. Technological advances have considerably altered the traditional relationship between displacement and fuel consumption. Modern engines incorporate technologies such as direct fuel injection, electronic control, and advanced ignition system management. These innovations enable engines to optimize fuel combustion, even with reduced displacement. Electronic management systems adjust the air-fuel mixture in real time according to driving conditions, improving fuel efficiency. What's more, engines fitted with turbochargers or superchargers can maintain high performance while minimizing fuel consumption. As a result, displacement is no longer the sole determinant of fuel consumption. Technological innovations have pushed back traditional limits, paving the way for more powerful, more fuel-efficient vehicles. Overall, understanding the relationship between displacement and fuel consumption is essential for consumers and vehicle designers alike, as it contributes to the creation of more energy-efficient transport solutions while maintaining optimum driving performance. Practical applications. When it comes to performance-oriented vehicles, displacement plays a key role in the quest for maximum power. Sports cars, for example, often equipped with large displacement engines to deliver rapid acceleration and high top speeds. This application of displacement aligns with the expectations of drivers who are passionate about automotive performance. In short, displacement directly influences the type of vehicle best suited to individual needs. From compact, fuel-efficient vehicles to power-hungry sports cars, cubic capacity remains a decisive criterion in the choice of a vehicle based on the specific preferences and requirements of each driver. The diversity of practical applications for displacement reflects the wealth of choices available to consumers in the modern automotive world. cc versus HP, how do they differ? cc, cubic centimeters definition, a displacement, measured in cubic centimeters, cc, represents the total volume of the engine's cylinders. It indicates the engine's capacity to admit a specific quantity of air-fuel mixture. Influence on power. In general, a larger displacement is associated with a higher power output capacity, as it allows for greater combustion of the air-fuel mixture. HP, horsepower. How to convert cc to HP? Converting cubic capacity, cc, to horsepower, HP, is not a straightforward conversion, as these two units measure different characteristics of an engine. However, there is a general formula that can be used as a reference, although it is not exact due to the many variables and the complexity of engines. This formula is based on an empirical estimate and can vary according to various factors, such as engine technology, efficiency, compression ratio, and other design considerations. The general formula for estimating horsepower, HP, as a function of cubic capacity, cc, is as follows: HP equals 22 to cc. Please note that this formula is an approximation and does not take into account the many other factors that influence engine power. What's more, the standard method of measuring a motor's power is to test it on a test bench, and actual power may vary according to a number of parameters. Frequently asked questions, FAQ, how is engine displacement measured? How does displacement affect fuel consumption? As a general rule, larger displacement is associated with higher fuel consumption, especially when an engine is subjected to high loads. However, technological advances, such as direct fuel injection and electronic management, mean that fuel consumption can be optimized, even with smaller displacement. Is displacement the only important criterion when choosing a vehicle? Understanding engine cc. In conclusion, understanding engine cubic centimeters, or cc, is essential for grasping the power dynamics of automotive performance. The size of an engine directly influences its power output, efficiency, and overall driving experience. By recognizing how cc affects torque and horsepower, drivers can make more informed decisions when choosing a vehicle that meets their needs. Whether you prioritize speed, fuel efficiency, or a balance of both, engine cc plays a pivotal role in shaping your automotive journey. Thank you for watching, and we hope this insight helps you navigate the world of engines with greater clarity.